So welcome to our session today. We're going to look at the TwoSum challenge. Basically what this challenge is all about is given an array of numbers. For example, 15, 11, 2, 8, 7. Okay. And a target x. Example maybe 9. Okay. In this array, look for two numbers that add up to 9. You can see that the two numbers will be this. Okay. There could be more, but for example here we just have these two. So you're looking for two numbers x, y, where x plus y equals to the target, which is 9. So simply what we can do is we can iterate over these numbers for each of the numbers. So for each x we look for y, the counterpart. So for each x find y, and therefore our y will be 9 minus x. And once we find the y that matches this formula, then that is the number. But remember, our question is also asked to return the index. Okay, so the brute force solution will be iterating over each of these, looking for the counterpart. And quickly, if we were to do the brute force solution for a pseudocode, will be for I, this index is up to the length of A. Length of A, we can denote it as this. Length of A will go up to -2, because the outer loop will need to go up to here, while the inner loop will be running from here to the last one, because we'll be looking at from the next to the end. Okay, so the inner loop will be 4j up to the length -1, which is the end of the loop. Okay, and then we want to find, now that we already have the target, we want to find our y. So given that our x will be ai, okay, our x will be ai, we want to find y. Find y. So y will just be target minus x, which is ai, and therefore we are checking if in this inner loop, if y is the same as aj, then that is our y. Then we return the two indexes, which will be I and j. So this solution, if we were to analyze it, I'll not cover big O notation here, but if you don't know much about big O notation, I will encourage you to read it up. But simple analysis of this would just be, this is taking n times worst case, and this is taking n times. So because they are nested loops, we're talking of an order n times n, or n squared. But there's a better solution, more optimized solution than an order n squared. And this is where, whenever you find that you're having to search, because this place here we are searching for y. Remember, we said find y. Whenever you find yourself searching for something, then that's a good place where you can apply a better data structure for doing that. and you can bring in, so most data structures for searching will be hash maps. Other languages call them dictionaries. So to go hash maps or dictionaries, hash sets, or just sets. So just call them sets. Okay, but because for situation here we needed to store both the index and the value, so a good key value structure would be a dictionary to use here, or a map. So because I'll be using JavaScript for this example, I'll use a map, and this is what you can do here. So just a quick explanation. What we are doing is we have a map. Our map is here, so let's just call it map here, and it has a key value kv. Okay, so at the beginning our map is empty. When we are starting off here, our map is empty. So but the computer does not know about whether the map is empty or not. Our algorithm will be that we check in the map if we can find the counterpart. So as we're looping through, this from I to the end, which is the length minus 1, we want to find the counterpart. And you know the counterpart was y, as we said, which is just the target minus the AJ that we are looking at, right? Okay, so at this point, when you look at 15, which is at index 0, right? Okay, 1 2 3 4 15, we are looking for the counterpart. The counterpart will be 9 minus 15 is negative 6. Looking for this negative 6 in this dictionary, we can't find it, so we keep going. Next, but before we go, we'll have to add that number in the dictionary. So the key will be the value of that, and the value will be the index. Okay, so the key is the value of that particular number in that array, and the value of the map is the index of A in that array. So 15 0, so that when we doing a lookup, we say where is 15? 15 is at 0. Where is 16 or 11? It's at 0.1. So next we look at 11. 11, 9 minus 11, what do you get? You get negative 2. Okay, we look for negative 2 in this dictionary, we can't find it, we keep going, but before we go, we add it in the dictionary. So 11 is at 1, then we go to 2, the counterpart is 9 minus 2, which is 7. We keep searching in the not searching really in the array, but we search in the map. And remember, when you're looking up, when the map is first, it's just order 1, the very first lookup. And when we get in there, we find that 2 is not there, so we keep going. We add 2 is at index 2, and keep going. We come to 8. 8, the counterpart would be 1. We look for 1 here, we can't find in the keys 1, so it's not there. We add it, and we keep going. Is at index 3. Okay, sorry, 8 is at index 3, and now we come to 7. 7, the counterpart is 2. Come in this dictionary, we find 2 is there. It's at index 2, so we found our solution. Okay, so basically we're just saying if this map that we have has y, then we found our solution. Just return map y, whatever has, or dot get, and I. So here map y will be map 2, which is at index 2. Just coincidentally it's 2 2, but could have been a different index, and therefore our solution here is just map y, which is 2, and the current index, which is 4. That will be our solution. Okay, so let's write out the code quickly. If anything here doesn't make sense, please reach out in the comment section. I'll be glad to explain more. So let's do a quick solution with JavaScript here. So function TwoSum takes in an array, the target. So the first thing we do is to create our map. So you can just say let m be new map, and I iterate through the array. So for let I equals to 0, I less than the length, which is a dot length, I plus plus. Okay, and what we are doing is say if m dot has, remember, no, sorry, we have to find our y first. So let y be target minus our x, our current x, which is ai, and therefore if m has the has function. Every language will have their own variant of this. If m has y, then we found our solution. So just return. This is the case. Just return. Get into the turn the index. The index here is m. So just not to confuse, remember the index will be m, y. This will be the index of where y is, and our current index, which is I. And if it's not there, we add it. So m set, we add the current sort of ai. Okay, so set ai and its index, which is I, and to keep iterating until the end. But remember our solution, so we could end up not getting anything. We have to return something like null, but from our challenge here they said there will be exactly one solution, so we are sure that at some point we'll have to hit this return. Thank you. That is the solution. Go ahead and do it yourself, write in your own language, and see you in the next one. Thank you.